Welcome to The Explainer. Today, we're going to explore humanity's long and, let's be honest, terrifying history with natural disasters. And we're going to look at this deep-seated need we seem to have to record them. A journey that takes us from personal horror to, well, planetary data.
Those moments when planets seem to line up, getting incredibly close. We're going to break down what's really going on up there. I bet you've seen it yourself. You're looking up one night and you see two super bright points of light way closer than they should be. And you think, wait a second, those aren't stars. That feeling of awe, that's exactly what we're diving into. It's a moment people have been experiencing for, well, forever. So here's our game plan. We'll start with the sheer beauty of the celestial dance. Then we'll get into the science of what a conjunction actually is. We'll check out the different planets and objects that can get involved, look at some of the most mind-blowing alignments, and then we'll zoom out for the big cosmic picture. I mean, it really does look like a perfectly choreographed dance, doesn't it? You can watch night after night as two planets slowly drift closer and closer, almost like they're waltzing, until they nearly merge into one brilliant beacon of light. It feels totally magical. But here's the thing. As magical as it seems, it's not magic at all. It's something way, way cooler. It's orbital mechanics. It's the beautiful, predictable, clockwork motion of all the planets, including our own Earth, orbiting the sun. So what do we actually call one of these cosmic meetups? Well, the official term is an astronomical conjunction. And yeah, that sounds a little formal, but let's break down what it really means. Okay, I know, that definition looks pretty technical with words like right ascension and ecliptic longitude, but you can ignore all that. The only part you really need to focus on is that last little phrase, as observed from Earth. That is the absolute key to the whole thing. Because that's what this all boils down to. It's a trick of perspective. It's a line of sight event. The planets aren't actually getting close to each other at all. They just happen to line up perfectly from where we're standing. Picture it this way. You're on Earth, you look up, and you see the moon. Got it? Now imagine that way, way, way out in deep space, the giant planet Jupiter happens to pass into that exact same line of sight. From your point of view, they look like they're right next to each other. And this is what's so wild about the illusion. The moon is, about 240,000 miles away. But Jupiter, it's over 400 million miles away. They're not even in the same celestial zip code, but for a brief moment from our backyards, they look like they could almost touch. And what's really cool is that this celestial lineup can happen with all sorts of different dance partners. It's not just two planets. You can get all kinds of interesting combinations up there. You have the most common ones, where our fast-moving moon seems to cozy up with a bright planet, like Venus. Then you get the classic planet-on-planet action, like when you see Mercury and Mars pass each other in the sky. And then there's a whole other category, the ones that involve our sun. So yeah, we need to draw a line between these two things. An apparent conjunction is the cool one we can see at night when two objects look close together. A solar conjunction, on the other hand, is when a planet lines up behind the sun from our point of view. Let's look at some real examples. So back in 2019, Mercury and Mars had a great apparent conjunction that you could see. But in 2026, Mars is going to be in solar conjunction. That means it'll be on the opposite side of the sun, and for us, it will be totally invisible, completely lost in the sun's blinding glare. So any conjunction is a treat, for sure. But some of them are truly once-in-a-lifetime events. I'm talking about the alignments that are so incredibly tight that the two objects practically merge into a single point of light. So how do astronomers measure this closeness? They use something called angular separation, which is basically the apparent gap between them in the sky. To give you some perspective, the full moon is about half a degree wide. The conjunctions we're about to talk about are a tiny, tiny fraction of that. Just look at that number, 0.000376 degrees. That is ridiculously small. What could possibly get that close in the sky? That, my friends, is the predicted separation for an absolutely stunning conjunction between Mercury and Mars that's going to happen on August 22nd, 2032. I mean, an alignment this close is incredibly rare. You won't be able to tell them apart. They'll just look like one single blazing star. Seriously, put that one on your calendar. And when you dig through the data, you find these other spectacular moments. Back in 1945, Mercury and Neptune had an unbelievably close pass. That 2032 event we just talked about is even closer. And looking ahead, in 2034, Venus and Mars will get super cozy, closer than the width of the full moon. It's amazing to see this intricate dance mapped out across time. Okay, so they look awesome, and some are super rare. But so what? Why does this really matter? Is it just a pretty light show? You know, this quote just nails it. That idea of a cosmic clockwork is everything. It was the fact that we could predict these alignments that helped early astronomers prove that the universe isn't just random. It follows laws. It's a system we can actually figure out. So, let's wrap this up. What should you remember? First, conjunctions are a beautiful illusion, all based on our line of sight. Second, they're proof of the predictable clockwork nature of our solar system. Third, they are the absolute best excuse to just go outside and look up at the night sky. And finally, they're just a great reminder that we live in a dynamic cosmos that's always in motion. When you think about it, all those dates and numbers aren't just dry data. Each one is a moment in time when the cosmic tumblers just click into place perfectly. Each one is basically an open invitation from the universe to stop what you're doing, go outside, and just feel connected to the whole thing. This celestial show is never gonna stop. For as long as we have a solar system, there will be new partners meeting in the sky. So the only real question left is, now that you know what to look for, what are you gonna see next?
But how do we record disasters today? Well, the approach has shifted dramatically. We've gone from storytelling to data logging, from, feeling the event to measuring it. Nowadays, we catalog catastrophes in spreadsheets and databases. Look at this list of volcanic eruptions. You see these names that just echo through history: Vesuvius, Krakatoa, but they're organized by date, by location, by their quantified impact, like the deadly pyroclastic flows from Mount Pelée, which are basically these superheated, crazy fast clouds of ash and gas. It's like a fiery ledger of our planet's most violent moments.
In this slide, it really captures the heart of that change. On one side, you've got Defoe, focusing on eyewitness stories and the hand of providence. And on the other, you have modern science, zeroing in on precise data, death tolls, economic cost, geological scales like the volcanic explosivity index. We've pivoted from documenting awe to performing analysis. And why? Because that analysis is what lets us build safer cities, write better policies, and ultimately save lives.
Now, this kind of systematic recording, it's not just for volcanoes. Oh no, it's part of this massive, coordinated global effort to catalog every major force of nature that threatens us. This universal human drive to understand our world, well, it now has a global digital memory. We have these amazingly detailed logs of Atlantic hurricanes that go back centuries. We track the dates, the locations, the death tolls, and you even find these strange little historical footnotes, like the 1766 hurricane that financially ruined the family of Napoleon's future wife, Josephine. How wild is that? And our gaze, it extends even beyond our own atmosphere, because this impulse to catalog threats, it really knows no boundaries. We're tracking dangers from 93 million miles away, documenting huge solar storms and how they impact our technology, from setting telegraphs on fire back in 1859 to knocking out entire power grids in the modern era.
So this whole effort is truly comprehensive. Organizations like the USGS and NOAA, they maintain these vast databases, creating a global ledger of our planet's most powerful moments. It's really an attempt to understand the rhythm of risk on a planetary scale, and that informs everything from, say, insurance rates to emergency response plans.
Okay, so all of this brings us back to that central question. From Defoe's handwritten letters to these global satellite databases, why do we do it? Why do we compile these grim catalogs of destruction and death? What's the impulse that endures through it all?
Well, it turns out the reasons are both profoundly scientific and deeply human. Of course, it's about survival, understanding patterns so we can prepare for the future, but it's also about memory. It's about honoring those who were lost, and it's about our fundamental need to find meaning, to recognize our place in a world that's filled with forces so much greater than ourselves.
And in the end, it seems the mission of a modern scientist isn't really all that different from Daniel Defoe's. His whole goal was to convey a memory to the ages to come. Today, we use data instead of poetry, but that core mission, to create a permanent record for the future, it's exactly the same.
From a single storm that shocked a nation
to a global network that tracks the very pulse of the planet, our methods have definitely evolved, but our reasons, our why, have not. So the question to leave you with is, what story will our data tell about us to the historians of tomorrow?
Let's start with a really modern and dramatic example, one many of us remember, the conjunction of 1989. So, right in the window of this cycle, two absolutely staggering things happened. In November of '89, that massive man-made structure of division, the Berlin Wall, it just crumbled. Then, a little over a year and a half later, in June of '91, a massive natural structure, the Mount Pinatubo volcano, literally dissolved itself into the atmosphere. I mean, just look at the incredible synchronicity here. You have a concrete political barrier, that's your Saturn, and it dissolves. At pretty much the same time, a solid mountain, another Saturn symbol, dissolves into a chaotic, formless veil of ash, hello Neptune, that literally affected the entire planet. Two totally different events, but they are singing the exact same song. Make no mistake, Pinatubo was not a small deal. This was the second largest volcanic eruption of the entire 20th century. It shot this enormous veil of ash and gas so high into the stratosphere that it circled the entire globe in just 22 days. It actually changed the color of our sunsets for years. So here's the kicker. This had a real, measurable effect on the entire planet. That huge atmospheric veil of aerosols caused global temperatures to drop by about half a degree Celsius. A planetary structure, our climate, was physically altered, which perfectly mirrors the theme of the theory. Have you ever wondered if the great disasters of history were truly random? What if some of the most terrifying moments on our planet were all connected by a hidden rhythm in the cosmos? Today, we're diving into a fascinating and pretty mind-bending idea suggested by our source material. So, let's set the scene. It's 1883. An entire island in Indonesia, Krakatoa, doesn't just erupt, it literally blows itself apart. The sound is heard thousands of miles away, and the blast unleashes monster tsunamis that just erase entire towns from the map. Now, let's rewind the clock way back to the year 1700. The coast of Japan is suddenly slammed by a giant wave out of nowhere. The weird part, no one felt an earthquake. There was no warning. It was like a ghost, a phantom wave, what scientists now call an orphan tsunami. Okay, let's jump forward to a time maybe our grandparents remember, 1952. A colossal magnitude 9.0 earthquake rips through Russia's Kamchatka Peninsula. It sends a tsunami racing across the entire Pacific Ocean all the way to Hawaii, causing incredible damage. Okay. So that's the theory, a 36-year cycle of planetary alignment linked to disaster. It's a bold claim for sure, so let's see if the history actually backs it up. Let's wind the clock back to the 18th century and start connecting some dots. All right, first up, the conjunction cycle, around 1701. The source material points to a window of a few years when the planets are at their closest, here from about 1699 to 1703. And what happens smack dab in the middle of that window in the year 1700? The Cascadia megaquake. And get this, remember that orphan tsunami that hit Japan? Well, that was the smoking gun. It turned out to be the key to a huge geological mystery. By studying those old Japanese records, scientists were able to trace the wave all the way back to a monster magnitude 9.0 quake off the coast of North America. It's pretty amazing, right? A record from one continent solved a mystery on another. Okay, let's tick the clock forward. About 36 years later, we hit the next cycle, the 1737 conjunction. The window of influence here is between 1735 and 1739. You can probably guess what's coming. And yep, right on schedule, another monster quake. On October 17, 1737, Kamchatka gets hit with a magnitude 9.0 earthquake. The tsunami that followed was just unbelievable. Some reports say the waves reached 60 meters high. To put that in perspective, that's like a 20-story building made of water. All right, now the third cycle of the century, centered around 1773. This is where things get even more interesting, because in this window, from 1771 to 1775, it's not just one thing that happens, it's a bunch of things. And what's really crucial here is that the activity is global. You have Japan getting absolutely devastated by the Great Yayama tsunami in 1771, killing thousands. And at the same time, halfway across the world, the volcano Santorini is erupting under the sea in Greece. This suggests the pattern isn't just a local thing. It's like the whole planet is on edge. Which brings us to the most famous disaster of them all, Krakatoa. And this event, as it turns out, lines up with what was an incredibly powerful and rare planetary alignment. So we look at the timeline. The conjunction window falls between 1880 and 1884. And sure enough, the cataclysmic eruption of Krakatoa in August 1883 lands right in the middle of it. Now, this right here is the heart of the argument. The 1882 conjunction wasn't just any old alignment. It was the tightest one ever recorded. From Earth, Saturn and Neptune looked like they were practically sitting on top of each other. And just 1 year later, our planet experiences its most famous, most violent volcanic eruption. It's almost poetic, isn't it? An extreme event in the heavens, followed by an extreme event on Earth. And the human cost? It's just staggering. The eruption and the tsunamis it spawned, some waves over 100 feet tall, killed more than 36,000 people. It's a number that's hard to even wrap your head around. So you might be thinking, okay, that's all in the distant past. Has anything like this happened more recently? Well, let's bring this timeline into the 20th century and see if the pattern holds up. The next major cycle covered in our source material centers around 1953. And right as that window of alignment opens in 1952, disaster strikes again. That's right, on November 4th, 1952, just a couple of weeks before the exact alignment, Kamchatka gets hit again. Another magnitude 9.0 earthquake, another massive Pacific-wide tsunami. It's eerie, right? The pattern as it's laid out here seems to just keep repeating. So, after laying all of this out, we're left with a big question. Is this all just coincidence? Or is there a real connection here? What does all this mean? I mean, let's just run through it one more time. It's like a drumbeat every 36 years or so. 1700, Cascadia. 1737, Kamchatka. 1771, Yayama. 1883, Krakatoa. 1952, Kamchatka again. That's 5 separate conjunction windows and 5 absolutely colossal geological events happening right inside them. So that leaves us with this final, really thought-provoking question. Is this just an incredible string of coincidences? Is it just our human brains desperate to find a pattern in the chaos? Or is it possible that our planet is tuned into a cosmic rhythm that we are only just now beginning to hear?
So, okay, we've looked at 500 years of these moments, and it all leads to one pretty obvious question. What happens now? Because this pattern, if you believe it's a pattern, is coming around again, soon. The very next conjunction of Saturn and Neptune is happening in February of 2026, and that's not far off at all. So it takes this whole thing out of the history books and puts it right on our doorstep. It really makes you wonder what big structures in our world are feeling a little shaky right now.
But look, this astrological theory isn't the only way people are trying to predict big events. The source material for this explainer also points to a totally scientific model. There are seismologists right now who believe they're seeing a chain reaction of earthquakes, a domino effect, building up in the Pacific. And it's leading them to forecast a massive earthquake in Kamchatka, Russia for July 2025. That's just a few months before the conjunction we've been talking about.
Yeah, this scientific forecast is based on something called Coulomb stress transfer. The simplest way to think about it is like dominoes. One big earthquake happens and it literally pushes stress onto the next fault line down the road, making it more likely to go. It's a completely different way to find a pattern in the chaos, based on physics you can measure, not on symbols in the sky.
So, okay, we've got a pattern, a cosmic clock that seems to line up with monster earthquakes. Case closed, right? We just need to watch the skies. Well, as you can probably guess, it's not quite that simple. Mainstream science has a very different way of looking at when and why earthquakes happen.
This mainstream view is called the Brownian passage time, or BPT model. The best way to think about it is, it's less like a predictable clock and more like a leaky faucet. You know a drip is coming eventually, but you can never predict the exact moment it's going to fall. The BPT model says that even though tectonic stress builds up steadily, there's all this random noise in the system that makes the exact timing of a quake fundamentally unpredictable.
So you've got these two competing ideas going head to head.
On one side, you have the cosmic clockwork idea, which suggests there's this predictable, external trigger. And on the other, you have the BPT model, which argues that it's all just a fundamentally random process governed by the messy physics of the Earth's crust. It's this fascinating clash between a really tantalizing pattern and the scientific embrace of randomness.
And this is where all the different threads of this story, the raw power of this region, that eerie historical pattern, the intense scientific debate, it all comes together and points toward one single, massive, looming question.
So let's just recap the mystery one more time. We have a region capable of absolutely gigantic earthquakes. Check. We have a historical record where its biggest disasters seem to align with a 36-year planetary cycle. Check. We have a scientific model that insists this has to be just random chance. Check. And we have the next planetary alignment happening very, very soon.
Well, the next conjunction is coming up, and it's coming up fast. February 20th, 2026. And astrologically speaking, this one is a really big deal. It happens at a point in the sky that's considered the very beginning of the zodiac. Think of it as page 1, chapter 1. A position that historically signals powerful, world-changing new beginnings. So based on all the previous cycles we've looked at, the analysis points to a few potential themes to keep an eye on. We could see major challenges to existing global leadership and power structures. The very idea of national borders might face dissolution and redefinition. And all of it may just point toward the birth of a powerful, and maybe a little chaotic, new global paradigm. It's a fascinating way to look at the past and the future, and it leaves us with one final thought to chew on. If history really does have a hidden beat, a predictable rhythm, what song are we about to hear?